All right, welcome. This video is going to walk you through how to find the factors and roots of this degree 4 polynomial. In doing so, you might be given the roots or you might have to find them. If you're not as fortunate as you are in this question to be given them, you have to go to your calculator into the y equals and then graph the equation. You'll see a graph like this if you adjust the window enough. You'll see it crossing at +1 and +2. It's also a good idea to use your table and verify that you see the coordinate 1, 0 in the table and also 2, 0. If you do that right now with this kind of question, you will see those things as well. Now, our goal is, again, like I said, to find the factors and the roots. Let's build this as we go along. So if you know you have roots at 1 and 2, we already know 2 of the 3 factors. Let's say then if you have a root at 1, your factor then will be the opposite of that number. It'll be x minus 1. If it also has a root at 2, like you see crossing the x-axis, you'll write it down a factor of x minus 2. Now, to find this mystery factor that we don't know yet, we're going to have to use synthetic division to take out each of these factors from this degree 4 polynomial. We'll do one at a time. If you're going to do this with synthetic division, you take the root value, you place that in the box. And then from here, what you're going to do is do the process. I'll explain it as we go through it as well. You take the 1, you drop it straight down. You multiply the 1 by, you take this 1 that you get here, you multiply it by the number in the box, which is your root. And you multiply those together and you get a 1. Then we add these two numbers together and we get -14. Then, that's a new number below this line. We need to multiply it by the number in the box. So we take 1 times -14, and that's going to give you -14. Now, I add those together, or subtract 14 from 123, and you'll have 109. Then I take 109 times 1, and I'll take that answer, which is going to give you +109 right here. Adding those, you're going to get the answer -170. And finally, when you take 1 times -170, you're going to get -170. And these two answers add to 0. That is a good thing. We want to find that when we take this factor of x minus 1 out of this degree 4 polynomial, we want to make sure it goes into it evenly. When you get a 0, that shows that. What also you might want to know about synthetic division, that this tells you the output when 1 goes into this equation. This is the output, and that's what you want to see, because when you have a root at 1, we want the output to be a 0, like you see right here. Now, let's do this again. We've now reduced this down to a cubic. It was degree 4, now it's reading as 1x cubed minus 14x squared plus 109x minus 170. If we take out the next root, we'll break it down to a quadratic, which we can use the quadratic formula with. Let's keep this going here. So I'm going to take my next root out of 2. So you just go like this, put a 2 down, and repeat the process that we just did before. Drop your 1 straight down again, you'll have a 1 right here. Multiply by the number in the box, you get 2, so that goes in the next column over. Those add together to get -12. You multiply 2 to -12, and you get -24. And then when you take 109 minus 24, you're going to get 85. And then finally take 85 times 2, that gives you 170. And again, that's a good thing, because we were hoping to see 0 as the remainder and also 0 as the output when 2 goes into the equation. Finally, what you have now broken this down to from a degree 4, then to a cubic, now it's down to a quadratic, which is degree 2 polynomial. This essentially represents the equation 1x squared minus 12x plus 85. So if we do the quadratic formula on this, we'll find our remaining factor. I'm sorry, this is the remaining factor. We have to decide if it breaks down further, but let me write it down now in the last factor spot. So I'll put down x squared minus 12x, and then plus 12x, sorry, a little bit nicer here, 12x plus 85. Now, if this does break down farther, if you use the quadratic formula and you get nice integer answers, which means non-decimals and non-complex with i's in them, then it breaks down farther. But if it does have an I in the answer or a long decimal that goes off your screen, then this does not factor. But what you're going to find is if you put a equals 1 into the quadratic formula and then b equals -12 and c equals 85, put those in the quadratic formula and try it out, you're going to realize that you have 2 roots that come out, and they are not integers. They are actually 6 plus 7i and 6 minus 7i. That tells you right there that this expression right here does not factor. So if you're trying to figure out what the answer is for your homework, this is as far as you go. You stop right here and don't break this down into 2 more parentheses. That's as far as it goes. Lastly, to finish the question, all you do is transfer those roots that you did get from this quadratic into your answer, and we're finally done with our 4 roots that we're accounting for, 6 plus 7i and 6 minus 7i. That's it. And now you've fully seen how to get through the homework questions, finding all the roots and all the factors of a degree 4 polynomial. Hopefully this video helps, and good luck on your question as you try to do yours.